Imagine a robot that can melt, slide through metal bars like it's made of butter, and then casually reform itself on the other side. Sounds like something straight out of a movie, right? Well, it's not. And the craziest part? Scientists have already built something pretty close to this in the lab. Welcome to Midnight DeepTek, where we break down the future after the headlines. No hype, just what's real and what it might mean for everyday life. Now, before your mind jumps straight to Terminator, let's slow down for a second. This isn't some killer robot from the future. It's not science fiction either. It's real science. It just sounds fake when you first hear it. And once you understand what's actually going on, it starts to make a lot more sense. Here's the first important thing. This isn't a fully intelligent robot with its own mind. What we're looking at is actually a special kind of material, a metal that can shift between solid and liquid states on command. So instead of picturing a robot with thoughts and decisions, think of it as a highly controllable shape-shifting material. At the center of it is gallium, a metal that melts at very low temperatures, barely above room temperature. Scientists mix in tiny magnetic particles. Then by applying external magnetic fields, they can guide it, stretch it, and reshape it, almost like digital clay. When the right conditions are applied, the solid structure softens. It flows like liquid through tight spaces and then pulls itself back together on the other side, regaining its original shape. Now here's the part the headlines usually leave out. This isn't some autonomous shape-shifting robot that thinks for itself. It's fully controlled by external magnetic fields. It has clear limits, and it's still very much in the experimental stage. And right now, it only works under very specific lab conditions. But the real promise isn't in sci-fi scenarios. This kind of material could be incredibly useful in situations where normal rigid machines just don't work. For example, imagine tiny devices that could travel through your blood vessels and deliver medicine exactly where it's needed. And because gallium shows up clearly on regular hospital x-rays, doctors could actually watch these devices move in real time like a glowing beacon on their screen. Or think about self-repairing pipes and infrastructure, materials that can automatically seal cracks before they turn into bigger problems. Even more interesting, scientists are testing gallium alloys as smart conductive liquid inks. So if a circuit board or pipe cracks, the liquid metal can flow into the gap on its own and instantly restore the connection. Basically, self-healing wiring.
While testing their new kind of liquid metal robot, researchers were able to solder a small LED into a hard-to-reach circuit by having it act as a universal screw. The robot melted down, filled a threaded hole, and then solidified to hold the two plastic plates together.
And then this same material could be used to create flexible robots that can squeeze into the tightest spaces, whether it's searching through collapsed buildings during rescue missions or assisting in delicate surgical procedures inside the body. These are the kinds of practical, real-world uses where a material that can change shape on command could quietly make a big difference. So no, we're not getting T-1000 Terminators walking around anytime soon. What we are seeing is the early groundwork for a new class of materials that can behave in ways we've never really had before. And like many important technologies, it starts small, looks completely strange at first, and slowly finds its place in the real world. Not as something dramatic and loud, but as something genuinely useful that quietly improves things behind the scenes. And that's what's really going on here. If you enjoyed these grounded, no-hype breakdowns of emerging tech, hit subscribe. This is Midnight Deep Tech. I'll catch you in the next one.